Hi everyone, welcome back to my YouTube channel. So today we are going to solve day 19 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 407, trapping rainwater 2. Okay, so this problem is marked hard by LeetCode, but by the end of this video, I'm going to make this problem little bit easy for you guys. Okay, so let's read the problem statement first. So we have given m into n integer matrix height map representing the height of each unit cell in a 2D elevation map. We have to return the volume of water it can trap after raining. Okay, so see these buildings. Okay, so there is unlimited raining happening here. Okay, so this is height map given to us. All right, so let's suppose this is A. Okay, this is B, and this is C. Okay, so now in the diagram, if you see this building, okay, this building, if you see, is of height 2. Okay, and then this building, if you see carefully, this building is of height 3. Okay, total 3 units, right? This building is also of height 3. Okay, this building is of height 2, right? And this building is of height 3. Okay, and this building is of height 1. Okay, so now why I'm showing you like this? Okay, so 2 3 3 2 3 1, so that is nothing but this C. Okay, this C block. Okay, 2 3 3 2 3 1. Okay, so this is C block, and then in between, if you see these buildings, okay, in between these buildings, okay, these buildings, so these buildings are of B block. Okay, so here starting from this 3, then maybe we have 2 1, and then this 3, then 2, and then this 4. Okay, this building height is 4 now, if you see this one. Okay, so this is B block, and behind this there is C block. Okay, behind this, so in the end we have a building of height 2, if you see carefully here. Okay, so here there may be some building behind it. Okay, so 1, then this building longest 4, then this 3. Okay, 1 3 behind it, and 2 here. Okay, so this is nothing but C block, and this is first one that is visible to you. Okay, this is nothing but, sorry, A block, this is nothing but B block, and this is nothing but C block. Okay, this C. All right, so now when we are going to trap the water inside these buildings, okay, only when we can cover the area. Okay, so definitely in the boundaries we can't trap the water. Okay, so here if you see, on top of this there is no water. No, we can't trap the water at the boundaries. Okay, at the boundaries, so only in mid part we can trap the water. Okay, and that is also only possible if the surrounding or neighboring buildings are of greater height. Okay, if the surrounding or neighboring buildings are of greater height, right? Okay, so now see here, I can write A like this: 1 4 3 1 3 and 2. Then I can write 3 2 1 3 2 4. This is for B, and C is 2 3 3 2 3 and 1. Okay, so we are not going to trap the water in the boundaries. Okay, so here there is no water trapped, okay, in the boundaries. All right, so now in the only mid part we can trap the water. Okay, only the if the surrounding buildings, okay, or the neighboring buildings are of greater height. So here if you see, this is 2. Okay, this building is of height 2. Here this building is having height 4, this building is having height 3, this building is having height 3. Okay, so that simply means that we can store some water. Okay, we can store some water, and here if you see, this building is having height just 1. Okay, and if you consider this building 1, okay, so here for this building 1, the side building is of height 3 greater, this building is of height 3 greater, this building is of height 3 greater. Okay, so here in between, that simply means that we can store some water, right? So let's suppose here one thing, there is one building of height 4. Okay, now in the surrounding, okay, here there is one building of height 6, in this side there is one building of height 8, in this side there is one building of height 12. Okay, and now here in this side there is one building of height 28. Okay, so now tell me how much water I can store in the mid part. Okay, definitely in the boundaries we can't store any water. In the mid only we can store some water. Then how what is the amount of water that I can store? Okay, so tell me. So that depends upon the building having minimum length, right? So here, out of these 6, 8, 12, and 28, which buildings of height, minimum height? 6. So how much water can store in this mid part is nothing but the minimum height of a building, surrounding building, that is 6 minus the height of this current cell. So this current 6 minus 4 is 2. Okay, this is very basic. Only 2 is the amount that I can store here. Okay, 2 is the amount of water that I can store on top of this building. Okay, 4, 5, 6, then at 7 all the water will overflow from top of this building. Okay, then there is no use of 8, 12, and 28. So it depends on the height of the minimum building, surrounding building, right? So this is important point. Okay, I hope that you guys are clear about this. Okay, so now here if you see carefully here, uh, building for this particular 2, okay, building height is 4, 3 and 3. So here out of these what is minimum? Okay, what is minimum? 3 is minimum. Okay, don't consider this right now, don't consider this one. Okay, out of these two, only one is minimum. Okay, so here let's suppose on top of this I store one amount of water. Okay, one is the amount of water. Then if you see this building, okay, so in this building out of these two, what is minimum? Okay, so here 3, 3 and 3, 3 is the minimum. Okay, and here also if you consider this side, okay, this building is having height 2. Okay, and then on top of it there is one more building. Okay, so here you just consider like this only. Okay, so 3 minus 1, so what is the amount you are going to get? Okay, so you are going to get here 3. Why 3? So 2. Okay, so here 3 minus 1, you are going to get 2 here. Okay, if you see carefully you are going to get 2 only. Okay, 2 amounts of water on top of this because the surrounding building height is 3 and this building is height 1. Okay, so 3 minus 1, you are going to get 2. Okay, and here 2 and here 4, here 3, here 3, and in this side also there is one building which is greater than 2, that is this 3. Okay, so 3 is the minimum, so 3 minus 2, you are going to get 1 here. Okay, and here this 3, here 1, all the water will overflow now. So here if you see this 2, here in this side 3, in this side 3, in this side 4, inside this side 3, so minimum is 3, so 3 minus 2 is 1. Okay, so in total 1 plus 2 plus 1, 4. Okay, so after the rain, water is trapped between the blocks. We have two small ponds, 1 and 3 units trapped. Okay, so total volume is 4. Okay, so this block, okay, 1, okay, 1 here, and here in this complete block, okay, 2. Okay, so why it is saying 2 ponds of 1 and 3? So this is of 1 and this is complete of 3. Okay, so here how can I represent? Okay, so see it like this. So 3, 2, 1, 3. Okay, just see this pond. Okay, I'm going to represent this pond, how it is working. Okay, 2, 3, 3, 2, and then we have 1, 4, 3, 1 here. Okay, so first you are going to check this building now. So this building height is 3, this building is height is 3, this building is height is 4. Okay, all right, now in the surrounding, okay, in the surrounding there is one smaller building. Okay, there is one smaller building, but if you proceed more further, okay, then check this. Okay, you can check this. So 1, 3 bigger, 3 bigger, 1. Okay, and here 3 bigger, so definitely there is one stop here, and in this side this is 2, and here this side 3. Okay, so what is bigger building? Okay, so 3 is a bigger building in this side, so 3 minus 1, 2 here, and here in this side 3, in this side 3, in this side 4, in this side 3. Okay, so 3 is the stoppage point, right? So 3 is the minimum, so 3 minus 2, 1. Okay, 1 plus 2, 3. Okay, so now this is just for visual representation. Okay, I'm also going to show you why here 1. Okay, what is going to happen, how I'm going to take 1 here, how I'm going to reach to the conclusion that this is going to be boundary. Okay, this 3 is going to be boundary. Okay, so I will show you, okay, with one more example. Okay, clear example. Okay, so here this is just for explanation purpose. Okay, how we are getting the output 4 in example number 1. All right, so now let's see, let's dry run, okay, on this example. All right, so first of all, what you need to do here, uh, you guys know that in the boundary cells we are not going to store any water. Okay, it is not possible to store water on boundary buildings, right? So what I'm going to do, I'm going to okay, first of all, let's give the index 0 1 2 3 0 1 2 3 4 and 5. Okay, so here this is nothing, I'm going to take a priority queue. Why priority queue? Okay, why priority queue? Because here I have told you that we need the minimum building. Okay, the height of the minimum building. Okay, so we are depending on the height of the minimum building. Okay, so I'm going to create one min heap in which I'm going to store the minimum height buildings on top of first. Okay, because based on this 6 only I can find the this na, I don't need to check for 8 12 and 28 then. Okay, if 6 is the minimum. All right, so what you need to do, okay, so here first of all we have to add the boundary cells to the priority queue. Okay, so here how I'm going to do, so first let's do one thing, let's add these, okay, and these, okay, these two in my priority queue. Okay, so how I'm going to add, so 12 is nothing but the height. Okay, and here I'm going to add 0 is nothing but uh, row, and 0 is nothing but column. Okay, 12 0 0. Okay, then 10, then this 9. Okay, 9 is the height. Okay, so 9 will come to the top. Okay, 9 and row 0 and column is 5. Okay, 905. All right, then 10. Okay, 10 I have to add, so 10 it will come in between. Okay, so let me do one thing now. Here 905, 905. Okay, here then we are adding what, 10, which is at 1 and 0. Okay, boundary cells I'm adding. Okay, then here we have 7, so 7 will go here directly. 7, okay, let me add this 7 here somewhere. 7 and at 1 and 5. Okay, so this is actually important. Okay, just understand this, how I'm feeling. Okay, so here 9 2 and 0. Okay, so 920 I have to add now. So here here 9 is already there now, so here let me add 9 2, okay, and 0, 920. All right, then we have 8. Okay, 8 is at uh 8 is at 2 5. Okay, 8 2 and 5. All right, and then we have this 8 uh, at 30. Okay, so 8 is already there, so one more 8, so here I'm adding 8 3 0. Okay, and then we have 7 at 3 5. Okay, so here 7 is already there, so here one more 7. Okay, 7 3 5. All right, so this is how we have to add. Okay, all this 715, then 735, then 825 830, then 905 920, then 1010 1200. Okay, so this is the mean heap based on the height. Okay, and also side by side do one thing, we have to, let's mark them visited. Okay, with green I'm marking. Okay, so let's mark them as visited. Okay, this is visited. Okay, this is visited, this is visited, then we visited this, then we visited this, then we visited this, then we visited this. Okay, then we visited this. Okay, done, clear. Now after that, here we have added the boundary cells. Okay, now these are also boundary cells, no? 12 10 10 12. Okay, all this stuff. So here now what we need to do, again iterate. Okay, again iterate over them. So here first of all, if you see this 12, Okay, so again 12, let's add now. Let's add. Okay, so 12, all right, at 0 0. Okay, so it's already there now, so you can do one thing, you can add it one more time if you want. So let's add that. Okay, no issues. So let me add this. Okay, 12 0 0. Okay, now column wise. So here I have added. Then this 10, 10 at 0 1. Okay, 10 at 0 1. So here 10 is already there, 1. Okay, so here let me add one more 10, 10 0 1. Okay, it is getting very okay tight here, right? 10 0 1. Okay, I have added this. Okay, done. Then we have okay, we have to add this also now, side to side. 12 and 8. Okay, both are at, it's not side to side. So 12 and then 8, 8 to 5. Okay, 8 to 5 is already there one time, so here I've added one more 8 to 5. Okay, so you can write here 8 to 5. Okay, 8 2 and 5. Okay, then we have to add 10 0 1. Okay, then we have to add 12 3 1. 12 3 1. Okay, 12 3 1 we have added, mark them as wasted. Then we have to add 12 12 0 2. Okay, so 12 0 2 I have added here, 12 0 2. Then we have to add this 11 3 2. 11 3 2 here, let me add 11 3 2. Okay, 11 3 2. Then we have to add this 10 0 3. Okay, 10 0 3 here is the last. Okay, so here we have to add 10 0 and 3. All right, then we have to add this 8 3 3. Okay, so 8 2 5, 8 3 0 we have, right? 8 3 0. Then we have 8 3 3 na, 8 3 3. Okay, getting very complex. Okay, 8 3 3. Okay, now we have to add this 12 0 4. Okay, 12 0 4. And then we have to add 12 3 0. Okay, so here let me add 12 3 4. Okay, so here what I had, 12 0 4. Now 12 3 4. Okay, 12 3 4, 12 3 4 we have to add. All right, then we have to add this 9 at 0 5. 9 0 5 is already there one time, so here we have to add one more 9 0 5. 9 0 5. Okay, 9 0 5. Then after that we have to add this 7 3 5. Okay, 7 3 5 is here one time, one more time you can add 7 3 5. Okay, so this is the final. Okay, so now just give me some time. Okay, let me just fix it. Okay, write it in order. Okay, so this is our priority queue. Okay, and now I have written like this. Okay, so first we have added this 7 1 5. Okay, so once we are ready with priority queue, okay, so I have to mark all these as listed. Okay, and you know that I am adding first like this and also like this now. So there are some elements like if you see here 830. Okay, so 830, first time when I was adding the boundary elements like this, and then later on I was adding like this also now, so that is why I'm writing 830 two times. Okay, same way 833. Okay, or 905 905 is occurring two times. Okay, so if you want to skip that, then you can do that. Okay, if you don't, then there is no issue. Okay, why there is no issue, I will show you. Okay, so this is our priority queue. Okay, so now in the priority queue, this is the minimum height first. Okay, this is the minimum height, right? 715 is the minimum height. That simply means 15 on this side. Okay, 715. Okay, so let me see if I can erase these few things. Okay, this looks good now. Okay, okay, all right. Now looks good. Okay, so first is this 715. Okay, so I am going to check this. Okay, so here this is brown color na? Brown color, so I'm going to mark this 7 in a brown color. Okay, current cell. Okay, so let me see, right, like this. Okay, 7 is my current cell. Okay, now for this, from this current cell, uh what are the neighboring buildings we have? We have this neighboring building here, we have this neighboring building here, we have this neighboring building here, and this is there's nothing. Okay, so this 9 is already beasted. Okay, don't do anything. This 9 is already beasted, don't do anything. Okay, this 8 is already beasted. Okay, do you see this green color? Okay, already beasted, don't do anything. Okay, so now this 8, this building is greater. There is one building 7, and then there is one building 8. Okay, out of these two, which is bigger? 8. So I have to take this as my boundary now. Okay, this 8 as my boundary. Okay, I have to take this 8 as boundary. All right, so now here this is 8 now, and now here what I'm going to do, see this white color pencil. Okay, so let's say this is white. Okay, white. All right, so here this is my boundary. Okay, this is my boundary. I'm going to treat this 8 as boundary. These 12, 10, 12, okay, all these things, these are also boundaries. Okay, these are also in white, and these are in white but also in green. Okay, I'm marking them as beasted as well. Okay, this is green also and white also. These are green also and white also. Okay, I have marked them as beasted. Okay, so now 8. Okay, so total volume of water, there is still no volume of water that we can store here, right, at this 8, because this 8 is greater than 7. Okay, so now I have to mark this 8 as my visited also. Okay, mark this 8 as visited. Okay, this is visited and also white. That simply means that this is also one boundary. Okay, boundary. So here first we pull this element in 715, and for 7 we are checking the neighbor. So do one thing here, remove this 715 from top on. Now we are done with this 715. Okay, now topmost element. Okay, one more thing, 8. Okay, 8 is the new boundary, so add this 8, 8, 1, 4. Okay, 8 is the height, 1 is the row, 4 is the column. 8, 1, 4 in the priority queue. Okay, 8, 1, 4, it will come where? It will come here. Okay, 8, 1, 4. Let me add this 8, 1, 4 with the white only, right? That side with the white. 8, 1, 4. Okay, let me add this. Done. 814 I've added. Now next building is 7, 3 and 5. 7, 3 and 5. 7, 3 and 5. Okay, this building brown color means current building. Okay, this is my current building. We have already visited this 8, we have already visited this 12. There is no building here, there is no building here, we don't need to do anything. That's it. Total volume of water is still 0. Okay, remove this. Here let me create one variable, total volume of water. Total volume of water, it is still 0. Okay, still 0. Okay, 735 again. 735. Okay, again it is, if you take this 735 as current, again there is no need. Na 735, there is no need. We have already pasted this 8, we have already pasted this 12. No need to check. Okay, remove this. So that is the why I'm saying that don't need to worry if we are adding duplicate entries. Okay, there is no issue. Okay, now 8 to 5, saying 8 is the height of building at 2 and 5, at 2 and 5. Okay, that simply means this 8. Okay, this 8. Okay, 8 to 5. All right, 7. Okay, this 7 is already based, this 7 is already based in, don't do anything. This is building, this building 10. 10 is greater than 8. Okay, this building is having higher water. Okay, so now what I'm going to do here, for this 10, first of all I'm going to mark this as boundary. Okay, if I'm marking this as boundary, so I have to add this here. 10 is at 2, 4. 10 to 4. Okay, let's add 10 to 4 here somewhere. Okay, 10 to 4. I have added 10 to 4. Okay, so if I am adding this 10 as a boundary, okay, and I am also going to mark this as visited. Okay, I'm going to mark this as visited. Okay, so from the smallest building we are going to visit the next building. Okay, neighbor building from the smallest only. So from the smallest only, from 6 only, I'm going to start the visiting the neighbor building. Okay, so that's the purpose here. Okay, so this 10 is done and I have added this. Okay, 8 to 5 is already done, so 8 to 5, let me move it from top of priority queue. All right, now in the top of priority queue we have 830. Okay, so 830, that simply means 830. Okay, 3 is the row and column 0. Okay, that simply means this brown color, this is my current. Okay, 830. So 830 now I'm going to take this, remove this. Okay, so here 12 is already visited, 9 is already visited, don't need to do anything, that's it. Okay, then again 830 is there, simply remove it now, simply remove it. Okay, so because we have already visited 9 and 12. Okay, so this is done. Now we have 833, that simply means that we are now at this 833. Okay, 833. Okay, 833. So last time we have it, this has boundary now, so I hope that you guys are clear what are the boundaries until now. Okay, so these are the boundaries until now. Okay, all this element outside. All right, so now we are at 833. 833. So first of all, remove this 833. I have removed. Okay, so this 11, no need to visit, already visited. This 12 is already visited. We can visit this. This building is having height greater 12. Okay, no. Okay, so here what I'm going to do, 12 at 2 3. Okay, so I'm adding 12 at 2 3 here. 12 at 2 and 3 here I've added. Okay, now 12 at 2 3 I've added. Okay, I'm going to mark this as visited as well. Okay, and this is one boundary as well, and I'm going to mark this as visited as well. So with the green color, let me mark it as visited. So this is also visited. Okay, so this is done. So now if you see carefully here, outside these boundary, out this okay, this shape, okay, this shape, everything is boundary right now. Okay, so now in the boundary, okay, so 6 3 2 13 15. Okay, these are the inside buildings, and right, and outside all are the boundaries. So outside, if you see 12 10 12 10 12, here 8, here this 12, here 8 11 8 8 8 is the minimum, and in the priority queue it is also showing 8, right, 814. Now it is showing 814. That is the use of priority queue. Okay, so from the minimum beginning, because my water is going to split from the minimum only, that is why I showed you this diagram in the starting. Okay, so from 4, first of all, water will flow on top of this. So here we are only going to store 2. So first of all, we are checking this 814 now. Okay, so current building, my current building, I'm always going to pick from the priority queue 814. So this is my current building. Okay, current building, marking this in brown color. Okay, remove this 814. Now see carefully what is going to happen. 814. Okay, so 814, if you see carefully, this 12 is already visited, this 7 is already visited, this 10 is already visited, this 2 is not visited yet. Okay, now this building is having height 8, and inside building is height having just 2. Okay, so now that simply means that we can store some water here, right? So first of all, how much water we can store here, tell me. The amount of water that we can store here is going to be 8 minus 2, that is 6, right? So 8 is nothing but the height of my current cell, 2 is the height of my neighboring cell. So total volume of water that I can store here at this particular position is going to be 6. Okay, so if here I have stored water, okay, here I have stored this much amount of water. Okay, so now what I'm going to do, okay, now what I'm going to do here. Okay, so now here, first of all, this I have added, right, I have added this. Okay, now in the boundary, what I'm going to add, so I am going to add a new cell in the boundary, right, and in the new cell I am going to add the max height. Okay, max height between the neighboring height or the current cell height. So here 8 and 2, which is max, 8 is max. Okay, so I am, see carefully this step. Okay, so here I have calculated total volume of water I am adding. Now I am going to, out of this 2 and 8, which is max, 8 is max, so I am going to make it 8 here. Okay, I am going to treat this 8 as boundary here. Okay, so we have buildings like this. So here we have stored 6 amount of water, and this is 2 is the height, right? So now this is going to become my new boundary. I'm saying this is my new boundary, and that is right, because in this particular part, if you see, we are only adding 6 amount of water. Okay, and now total height is still 8. Okay, so now in the this I'm going to add what? I'm going to add 8, and 8 is at which row? 1, and at column 3. This is what I'm going to add. Okay, and I'm going to mark this as visited and a new boundary. Visited green, right, and white for boundary. Okay, so now if you see carefully, these are the only remaining part. Okay, and outside all are the boundaries. Okay, and now in the outside, okay, the boundaries touching this 6, 3, 13, 15, you see the smallest one is just 8. Okay, so 6, 3, 13, and 15. Okay, so here 10 and 12, and here 8 and 12 is there. Okay, and here 12 and 11 is there, and here 9 and 10 is there. Okay, and smallest building that is touching is 8, and at priority queue on top of this we have 8. Okay, so now, right, I am making this question easy for you, right, little bit, right? So now my current is going to be this 8. Okay, my current is 8. Okay, so now 10 we have already visited, this 8 we have already visited, this 12 we have already visited, now this is 3. Okay, so first of all, how much water I'm going to store? 8 minus 3. 8 is the height of this cell, and 3 is the height of the neighbor. 8 minus 3 is 5, so 5. So 6 plus 5 I have to do here, so 6 plus 5 is 11. Okay, 11 is the total volume water right now, and here 3 and 8, which is max? 8 is max. Okay, so here I'm going to change it to 8. I'm going to change it to 8, and now I'm going to add this 8 in my boundary. Okay, 8 at 1 and 2. Okay, 1 and 2. Previous one I have removed, and here I have added 8, 1, 2. Okay, 8, 1, 2. And now this is I'm going to mark this 8, 1, 2 as visited. Okay, and this is also my new boundary. Okay, this 8 is new boundary. Okay, now we are left with 6, 3, and 15. Okay, 6, 3, 13, and 15. So out of this, now for this 8, okay, for this 8, this 12 is already visited, this 8 is already visited, this 15 is not visited, this 6 is not visited. Okay, so now first of all, which direction you want to move, you can move to any direction, that doesn't make any problem, right? So here if you see this neighboring building having height is smaller, so 8 minus 6 is 2. Okay, so add 2 here, so total is going to be 13. Okay, 13, and 8 minus 6 to 13. Okay, so here I'm going to make it to 8. Okay, and I'm going to add this 8 at 1, 1. 8 at 1, 1. Okay, 8 at 1, 1. I'm going to add this one you can remove now, because I'm checking from 8, 1 to 1. Okay, 8, 1, 1 I have added. I'm going to mark this as visited. Okay, with this, and I'm going to set it a new boundary. Okay, new boundary simply means with white. Okay, now from this same 8 we can go to this neighbor as well, na? 15. This is having height 15, greater height. Okay, greater height. Then what we need to do? This is having small height, this is having greater height, then there is nothing we can do, right? There is nothing we can do. Okay, so we are just going to move with 15, we are going to make it a boundary and mark this as visited. Okay, that's it. So this is what we were doing, right? Mark this as visited, and this is boundary. Okay, so only 13 is left, and on top we have 8. Okay, so 8 we are going to take, and here it is 13, bigger building. Okay, so remove this bigger building, so here let it be 13 only. Okay, we are going to keep it 13 only. Okay, that's it. That's it. So in the end, what is total volume of water that I'm getting? 13. Okay, so 13 is going to be my output for this particular problem. Okay, so at 13 we have to stop. Okay, because we have visited all the cells. So we are running one while loop. Okay, until my priority queue becomes empty. So here it will become empty. Okay, because we have already visited all the cells. So if you pick this, already visited all the neighbors, you pick this, already visited all the neighbors, so it will become empty. Okay, there's nothing to visit now. So final end result is going to be 13 only. Okay, so now let's write the code. Okay, and I'm going to explain everything in code as well. Okay, what and how we need to do. Okay, all that stuff. So let's move to the coding part, and there are going to be hardly, I think, 40-50 lines, so don't worry. Okay, I will explain very good way, right? So what you need to do now? Okay, so here one more thing. Okay, if you are new, if you already know, if you already watched the tutorials on this channel, then you already know how we write the directions. Okay, but if you are new, then let me write it one more time. Okay, so that's why you are here. Okay, and let's suppose this is one grid. Okay, and here we have 0 1 2. Okay, rows, columns 0 1 2. Okay, so now if you are going up, okay, from here to here, okay, so in the you are in the same column, right, but your row is subtracting by 1. Okay, so 1 to 0, right? So here I can write 1 minus 1, and here I can write 0. Okay, so this is for up direction. Okay, minus 1 comma 0, right? Because here from this cell, if I'm moving to this cell, so my row is decrementing, right? 1 to 0, but my columns are remaining same, right? So this is minus 1 0 for up. Okay, same way if we are moving to this direction, so here column is incrementing by 1. Okay, and row is going to remain same. So this is for moving to the right side. Same way if we move to the left side, then my column is going to be decremented. Okay, so column is going to decremented and my row is going to remain same. And if we are moving down, then my row will be incremented, right? So here 1 and 0. Okay, so these are nothing but directions. Okay, so directions. Okay, so here these are rows. Okay, this side rows, rows, and these are columns. Okay, these are the columns. Okay, so now I have to create two array. Okay, one is for direction in the row side and one in the direction in the column side. Okay, so here total 4 directions we have, right? So here instead of using 2D array, I'm using 1D array. Okay, so here what I'm going to do, I'm going to write here 0. Okay, and here d equal minus 1. So 0 minus 1, that simply means that we are moving to the left side. Okay, 0 minus 1 for left. Okay, all right. Then if I'm writing here 0 and here I'm writing 1, that simply means that in which direction? 0 and 1. See, then that simply means that we are moving to the right. Okay, and if I am writing here minus 1 and below 0, minus 1 and here 0, so that simply means that I am moving up. Minus 1 and 0. Okay, I'm moving up. And if I am writing here 1 and here I'm writing 0, that simply means 1 0, that simply means I'm moving down. Okay, so LRUD. Okay, so this is how I'm going to create two arrays. Okay, so let's write that. Okay, so let's make this code easy for you. Okay, so int d row is equal to, write same thing. Okay, here 0 comma 0 minus 1 comma minus 1. All right, and here d code is equal to minus 1 comma 1 comma 0 comma 0. Okay, this is done. Here these are nothing but my directions. Okay, now let's calculate the number of rows and number of columns. This is actually requirement, right? Number of rows and number of columns, and in one go I am going to add these two boundaries and add these two boundaries. Okay, in a one go. Okay, in a single loop I'm going to do this. Okay, so for that purpose we need number of rows and number of columns. Okay, so here int num rows is equal to this height map dot length. All right, and num calls is equal to height map at 0 index. Okay, pick first row, and in first row's length, if you calculate, you will get the number of columns. Right, done. Okay, so now after that we have to take one visited array as well. Okay, boolean visited, and here new boolean same. Okay, we have number of rows and number of columns, right? So here I'm going to write num rows, and here I'm going to write num calls. All right, this is done. Okay, now we have to add all the boundaries in our priority queue. Okay, and in priority queue the cells that I'm adding, so what I'm adding height, then I am adding row, height, row, and column. Okay, all these things I'm adding. Okay, so here I'm going to create priority, priority priority queue. Okay, and here inside I'm not passing integers, I am passing cells. Okay, consisting of height, row and column. Okay, so here I'm going to create one class cell. Okay, so here I'm going to pass cell. Okay, I'm going to create one class. Okay, in that class I'm going to define a constructor with all the parameters like height, row and column, all that stuff. Okay, so here let's name it as boundary, new priority queue. Okay, priority queue. Okay, now I want this priority queue to work as min heap as well, right? Based on height. Okay, smallest height we should come to the top. Okay, so before writing further, okay, here before writing further, let me write the code how these values are coming here. Okay, from this side. Okay, so here you can write private. One second. Here you can write private static class, and the name, give the name as cell. Okay, this cell. Okay, but I'm passing here cell. All right, so this is going to implement. I have to compare based on their height, so let's implement it with comparable of the cell. Okay, this is what we need to do. Okay, so inside this we have three things, right? We have height, we have row, and we have column. Row, and then we have one column. Okay, so these three things we have. Okay, now constructor. So here public cell. So in this we have total three things now. So int height, int row, okay, int col. All right, so here just I'm passing this dot height as height. Okay, height is equal to height, then this dot row is equal to row, and then this dot col is equal to col. Okay, this is done. Should be like this. Okay, this dot height is equal to height, this dot row is equal to row, and this dot col is equal to col. Okay, this is done. Then after that, compare to, we have to compare them based on their cell. Okay, so here let's define this. Okay, public int, and here my function compare to. Okay, so this function is going to take one parameter. Okay, cell other. Okay, and now but it is going to return, it is going to just return. Okay, so we have integers. Okay, which we are comparing. So integer dot compare. All right, so what we are comparing, we are comparing the height or other dot height. Okay, this dot height, and here other dot height. Okay, so this is how it is going to work. Okay, basic purpose of this cell is to take three total values, height, row and column, and then sort them based on their height. Okay, done. So this is done here. So here we have to add the semicolon. Okay, done. Okay, so that's it. So now main code. Okay, and main code is very simple, you already know what we are doing. Okay, so now first of all we have to add the boundary cells. Okay, so first of all let's go 0 1 2 3 and keep this column as fixed. Okay, which is 0, and this column as total length of number of columns we have -1, so 5. Okay, so in one go I'm going to do this. Okay, so add boundary cells for int I is equal to 0, I is less than num rows I plus plus. Okay, inside this boundary dot offer we are passing new cell. Okay, and in this cell what we are passing, we are passing total three things, that is height map at index I. Okay, I is changing every time, and we are making the column fixed. Okay, 0, and also I am passing row, and I'm passing column. Okay, so this is for these columns. Same way we have to write for these columns as well. Okay, so here you can simply copy this line, paste it here. Okay, now here what there are some changes that you have to do. Boundary dot offer new cell height map I, and here column is going to be number of columns you have, number of calls minus 1. Okay, and here I, and here you have to pass column as num of calls minus 1. That's it. Okay, done. Now I am also saying that mark it as visited as well, side by side. So we have to mark which two cells visited. Okay, visited of 0 of I. Okay, this we have to mark as visited. Okay, this side and this side, both side. Okay, so visited of 0 of I is equal to visited of, it is I comma I of 0, right? I 0, column is fixed now. Here I, and here num calls minus 1. Okay, these two. Okay, so we have to mark them as true. That's it, is equal to true. All right, this is done. Okay, now this is for this side. Now same way we have to do for this and this side. Okay, this and this side, so same code. So copy this. Instead of num calls we have to write num rows, or num calls then num rows. Okay, so here num rows change it to calls. Okay, few changes. Okay, then boundary dot offer new cell. Here this is going to be 0 and this is going to be fixed. Okay, opposite. And here this is going to be 0 and this is going to be I. Okay, then boundary offer new cell height map. Here this is going to be I. Okay, this is going to be I, and here this is going to be num of rows minus 1. Okay, and here simply you can copy this, paste it here, num of rows minus 1, and it should be I. Okay, this is done. And here also it is 0 and it is I. Okay, and here it is num of rows minus 1, and here it should be I. Okay, that's it. So until here you guys are clear, right? Done. Okay, so now only 5 6 or 10 lines of command. That's it, nothing else. One simple while loop. Okay, so here in the end we have to return the total water volume. So create one variable there for that, result, or gives this name. Okay, total water volume is equal to 0 in the starting. Now while my boundary is not empty, boundary is not empty. Okay, so while my boundary is not empty, so take particular cell first. Okay, current cell. Okay, brown color, remember. So boundary dot call. All right, now we have to check in all the directions, right? So run one loop for int d is equal to 0, d is less than 4, d plus plus. Okay, and here next no row and next call, how we are going to calculate? nr is equal to, for that particular, take the row cell dot row. In this row we have to add d row. Okay, d. Okay, so here we have taken a d row, so d row of d. Okay, so it is just going to add 0 1 accordingly. Okay, so d row of d. Okay, same way how we are going to take next column, nc is equal to, take that particular cell dot call. Okay, and in that cell we have to add d call of d. Okay, so this guy you guys already know now, right? So here let's suppose I am at this cell. Okay, 1 1, I want to move to this side. Okay, so if I want to move to this side, that simply means I want to move to 1 and 2. Okay, so here what should I add in this 1 1 so that I get 1 2? So I am moving to right. So at right, what we have 0 and 1. Okay, 0 and 1. So 0 here, 1 here. So add these two, 1, add these two, get 2. Okay, 1 2. That's the simple meaning. Okay, clear? This is very basic actually. All right, so now here just make sure that our next row and next column is valid. Okay, so you can create one separate valid function or simply write like this: nr it should be greater than equal to 0, and nc also should be greater than equal to 0. Okay, and nr should be less than num rows, and nc should be less than num calls. Okay, this is just for valid purpose. Okay, and here important thing, and we haven't visited that particular cell. Okay, then only we have to check further. Okay, visited of nr and nc. Okay, same story that I have explained, I'm going to write the same thing. Okay, done. And inside this, now neighbor height, we have to calculate neighbor height na? And then we have to check further things. So here neighbor height is equal to height map, and here I'm passing nr and nc. All right, now here base condition. Okay, we have to check. So here not base condition, but here if my neighbor height is less than cell dot height, okay, only in that case we have to increment the total water volume. Okay, so total water volume, okay, if a neighbor height is less than cell dot height, in that case my total water volume is going to be total water volume plus my what is my cell height. Okay, cell height, from this cell height I have to subtract my neighbor height. Okay, only if this condition is valid. Okay, neighbor height. All right, otherwise not otherwise, but always we have to add the new cell. Okay, neighbor cell to our boundary. Okay, boundary dot offer, and you guys already know we are going to add the max. Okay, new cell I'm adding, and in the new cell what I'm adding height, I'm adding the height as math dot max of what, math dot max of neighbor height, yeah, or cell dot height. Okay, cell dot height. All right, and here we have to add next row and next column. Okay, row and column we are adding every time. This is done, and now we have to mark it as visited as well. Okay, so here visited of nr and c, I'm going to set it to true. Okay, and in the end we have to just return the total water volume. That's it. Okay, so here this ends, and here see just 37 lines of code, right? Return total water volume. Okay, now let's run it and see if there any code issue. We'll try to fix that. So yes, so I think spelling mistakes maybe. So let's see this C. Okay, so here inside this was, we have to take this cell now, small one, see. Okay, so this is the object I'm creating for this cell, so this should be small c. Okay, is there any other issue? Let's see. Okay, now where, here private public int compare to cell other return integer dot compare this dot height, and here other dot height. What is the issue here then? One second, let me go here. Variable height spelling mistake, right? HEIG, that's what I think. While writing also I was thinking about the same, that maybe I have written the wrong spelling here. Okay, so see, all the test cases has been accepted, right? And here 1 4 3, what is example? I have explained this with this example, right? 12 10 12. Okay, so can I write, let's write now. Okay, so 12, let me go here, create a separate test case, or here only I can write, right? So here let me just read. So let's run it. So 13, right? So this is what we are getting, right? 13. Okay, so let's submit it. So there is some issue, let's try to fix that. Okay, so see here, 0 0 minus 1 I'm writing here, it should not be now like this. So where are directions? 0 0 minus 1, it is 1 now. Okay, it is 1, it is not minus 1. Okay, so now let's submit it. So that is why I think we are getting this issue. So see, all the test cases has been accepted now. Wonderful. Okay, so I hope that you guys are able to understand today's problem. And now time complexity part. Okay, that is very important. So here we are running for number of time. Okay, so of n for this part, of n, of n here. Okay, and then here if you see number of columns time, so here you can say of m. So overall here of n, here of m for this part. Okay, but here also now inside this we are adding the elements in the priority queue. Okay, so you know the priority queue operation that it's going to take log of time, log times this log of n. Okay, of n log n, and here of m log m. All right, and here if you see this while loop, so inside this while loop we are, what we are doing, we are adding the elements to our priority queue and we are polling. Okay, so poll and adding the elements priority queue, it is always going to take a k time complexity. K is nothing but m into n. Okay, number of total cells, so log m of n, and we are doing this for m into n columns, right? So mn log mn is going to be time complexity. Okay, so let's see if we are able to see the time complexity from here. So yes, m into n log m into n. Okay, so I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you, bye bye.